First, let's take a look at how we would graph f of x equals 1 over x minus 4. If we think back to the parent graph, y equals 1 over x, we graphed that a few chapters back. Actually, may have been a while since you graphed that one, but it's 1 over x goes through 1, 1, and 2, 1/2, and 1/2, 2, and has asymptotes at both axes. So this is the graph of y equals 1 over x. So when we graph f, that's the same graph, just shifted to the right 4 units. So 1, 2, 3, 4. So that would be the same graph with the vertical asymptote here. It's not shifted up or down, so the horizontal asymptote is still in the same place. And so our graph is going to look like this and this. So that's f of x. Now what we're asked to do is this function g. And since x is replaced by x plus 2, that's going to shift our graph left 2, and the minus 1 is going to shift it down 1. And so if I take that red graph and I shift it left 2, the vertical asymptote would be here now, and down 1, the horizontal asymptote would now be here. And so now our final graph for g is going to be this green graph. This problem also asks us to write the explicit equation for g of x. So that means what is the actual function for g of x? Now we'll start with f of x is equal to 1 over x minus 4. And so then whatever we put in for x, we also have to put in for this x. And so then g of x is equal to f of x plus 2, which means we're putting x plus 2 in place of that x. So we have to put x plus 2 in place of that x also. And then it also has a minus 1 at the end. And so that's going to be 1 over x plus 2 minus 4 minus 1. And so that is 1 over x plus 2 minus 1 is our function g of x. And notice that that is also just a transformation of our original parent graph 1 over x. This is moving it to the left 2. I'm sorry, this should be a minus 2 because it's 2 minus 4, so minus 2, so that's actually right 2. And the minus 1 moves it down 1. So compared to our parent graph, it should move right 2 and down 1. And so if we go back to our blue graph over here, we see our blue graph, if we moved that right 2 and down 1, then that point here would end up here. And so that gives us the same graph as we got when we produced the graph the other way. So now we have our explicit function, and we have our green graph as our graph of g of x.